So welcome to the Resnet demo on the NVIDIA Jetson TX2 platform. Here we are actually going to implement the Resnet 50 model um, on the NVIDIA Jetson TX2. So let's just dive in and see what we are going to do in this video. So on the GitHub repo, I've explained what actually a Resnet is. So it's a really deep network with say 50 or 100 layers. It's really deep, and the important part is the shortcut. So these networks have a problem of vanishing gradients, huge deep networks, but these skip connections or shortcuts allow to address this problem of vanishing gradients by actually passing in the input to the output and then directly adding it to the output. So there are two main blocks of types of residual blocks, which is the identity block and the convolution block. So identity block by name will pass just the input to the skip connection and to the next output, or it will skip 3, and the convolution block will actually have an activation in the skip function and then pass it. So this is the complete implementation of Resnet 50 model in Keras. There are plenty of repos available. The important thing is average pool is used in Resnet, which is not used anywhere else, I guess. We have trained it on the signs dataset, which is basically hand signs of 1 to 5, and you've used adim. The input dimension is pretty low for this kind of dataset. It's 64 by 64 only. I suggest that you use higher dimensional datasets because the Jetson camera is really good and it can capture that much, and you can use that to predict the the image classification things. The important other fact is that the Resnet is a huge model, so implementing this on the Jetson is not possible. So we trained it on a GPU, the Titan X GPU, and then implemented it on the Jetson. The main reason is because of the memory. The Jetson will run out of memory and the training will be really slow. Again, even if I am loading the model, it is also running out of memory, so we have reduced the size of the model as much as we can. So it's not exactly Resnet 50, but it has the features of Resnet 50. In test on cam.py, we have taken the onboard camera and passed the frame with OpenCV with a dimension of the input dimension that we have, which is 64 by 64 at a rate of 10 frames per sec, but you can actually increase it. I'm just reducing it because I don't want to burn the Jetson, because already the memory is going to become a problem in this type of thing, because the model itself is pretty huge. But you can try smaller models for simple implementations. Here we actually pass the frame to the model and use the model.predict function and print the maximum value or the softmax output, which will be the predicted class. So let's run a demo of it. The GitHub repo is pretty detailed and it shows the training and the testing accuracy that we got, and it was around 90%, which is good for such a small data set with such a low resolution. So let's actually try to implement this on the TX2. So keep an eye on the memory and to see the graph, it just bumps up like anything. And still, Jetson is a really powerful microcontroller. So I have a image which is printed of the sign dataset, and And there you go, it actually predicts pretty accurately. Again, the image is blurry because we are passing a 64 by 64 resolution only. So if you definitely try to pass a higher resolution, and maybe you get accurate results. I'm just concerned more about the memory, and I just want to keep the code as simple as possible because the model itself is huge. So you can definitely try reducing the size of the model, increasing the size of the input image, and see what it does to the prediction. It will not hamper much, but again, it's on you. Here on what I'm talking about, we are actually using 85% of the memory, so the Jetson may run out of memory anytime with a simple Keras code. Probably it's going to be much more enhanced in some ways by reducing the size